Good morning. As you know, our thesis constantly relies on a delicate balance between cell proliferation and cellular maintenance. This balance is essential for life, but when it fails, the consequences are severe. Its cells grow uncontrollably, we develop cancer, but also its cells are incapable to maintain themselves and repair damaged tissues age and degenerate. Understanding how cells make these decisions is one of the major challenges in modern biomedicine. Normally, these kind of decisions are controlled by signaling pathways, which are like communication systems within the cell. One of the most important knowns is the mTORC1 complex, which is a protein complex involved in cell growth, metabolism, and autophagy. Autophagy is also related with age-associated diseases when deregulated. In our lab, we've been studying a protein called SOC2, which is a protein involved in the MAP kinase signaling pathway, which is involved in proliferation and cell survival signals. It's demonstrated that SOC2 is capable to interact with Raptor, a subunit and a key component of the mTORC1 complex. And this is really exciting because SOC2 could be acting as a molecular switch. Give me a second. A molecular switch like this between the proliferation signals of the MAP kinase signaling pathways and the cellular maintenance and aging signals of the mTORC1 signaling pathways. So to explore this idea, we generated SOC2 knockouts in which we eliminated the SOC2 gene in cell lines, and we saw interesting results of responses in signaling pathway alterations. One of the most interesting is related with a reduced proliferation and an increase in the senescent-related signals. That supports our model of SOC2 acting as a molecular switch between proliferation and aging. So these suggestions are interesting for future opportunities. For example, in cancer, SOC2 could be acting as a modulator to limit and control proliferation in tumoral cells. In aging, for example, understanding the mechanisms of cellular maintenance could also be good for the healthy and better aging, and also the SOC2 levels could be used in aging biomarkers in order to understand how cellular balance is controlled during cellular aging and aging disorders that affects thousands of people every day. So if we want to break one of the biggest walls in biomedicine, we have to understand the molecular switches that regulate the cellular behavior. And one of those switches might be SOC2. Thank you so much.